Hello everyone, this is N. Kavita, working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to see the basic introduction to microsensors. In general, we are aware that a sensor is a device that converts one form of energy into another, and it provides the user with a usable energy output in response to a specific measured input. For example, the input may be of any kind of physical, chemical, biological quantities, and these inputs are sensed and it is converted back into electrical signals. These microsensors are the miniaturized sensing devices that is used for this detection purpose. They play an integral part of MEMS technology, which combines microelectronics with micromachining techniques to produce a compact and high efficient sensors. Miniaturization, integration, low power consumption, mass production, and high sensitivity are the key features of microsensors. Microsensors plays its application in various industries. For example, in automotive industries, here in case of car airbag deployments and tire pressure monitoring, this microsensors plays a major role. It also plays its importance in consumer electronics, where they are induced in the gyroscopes, accelerometers, and microphones. It also plays a major role in medical devices. It is used in implantable biosensors and glucose monitors. It has its own role in industrial systems where it is used to monitor your vibrations and sense the pressure. There are various types of microsensors. The few are listed here. The first one is the acoustic wave sensor. This sensor particularly converts the sound wave into an electrical signal. And then biomedical sensors and biosensors, where the biological substances are detected and converted back into the electrical signals. Next is the optical sensor. We all know that the input would be the light source. The light source is converted back into an electrical signal. Pressure sensors, where the input pressure is converted into an electrical signal. And thermal sensors, here the input is going to be the temperature. By sensing the temperature, the thermal sensors converts it into an electrical signal. So apart from all these basic sensors, there are physical sensors like accelerometers, gyroscopes, chemical sensors, where it is MEMS gas sensors are majorly used to detect the presence of the chemical gas. Apart from that, as we discussed already, it is used in healthcare to detect the biomolecules, glucose levels, and pathogens. So microsensors has its own applications in various fields. And in this particular topic, we are going to see what is the acoustic wave sensor. So an acoustic wave sensor is an electronic device that is used to measure a sound level. They are called the acoustic wave sensors because of the detection mechanism. They are able to detect a mechanical wave, or it is also called as an acoustic wave. When you see here, there may be a wave and there we have a particular transducers. So when this acoustic wave or input is traveling through a specific material along a surface, it is influenced by different metallic properties and obstacles. So based on the changes to the characteristics of this traveling path, maybe the velocity or maybe the amplitude of the wave, these characteristics are translated into a digital output by using a transducer. So let us look back into the construction of the acoustic wave sensor. So when you see the acoustic wave sensor, generally it is made up of a piezoelectric substrate, and this piezoelectric substrate is required for converting an electrical signal into a mechanical wave. As you see here, there are the two interdigit electrodes, or in short it may be called as IDTs, and this interdigit electrodes are nothing but it is a metal electrode which is patterned onto the substrate. So whenever you apply an electrical signal to this electrical port of IDT1 and IDT2, it generates the acoustic wave, and this acoustic waves will travel along the piezoelectric substrate. And now what happens actually is, now the acoustic wave generators is influenced by the pressure or stress, and with the help of this IDTs, it is converted back into the electrical signals. These electrical signals are used for the measurement. So when you look here, we should know what is all about a piezoelectric substrate. So in general, a piezoelectric substrate is a base material for all kind of sensors when you manufacture. So it is made up of a piezoelectric material like quartz, lithium niobate, or zinc oxide. These piezoelectric materials can convert your mechanical pressure into a electrical energy or vice versa, which in case whenever you apply a mechanical pressure, the output end will get the electrical signal. Or if you produce an electrical signal in the input end, due to the mechanical deformations, you can obtain the electrical energy. So when pressure or mechanical stress is applied to this particular substrate, it actually generates an electrical charge. Or if you apply an electrical signal, it produces the mechanical vibration. So this is the major role of the piezoelectric substrate, and it is the most important part of the sensor. So now let us look into the operation of the acoustic wave sensors. So when you look into the operation of these sensors, we all should know that the piezoelectric substrate is a basic part. Whenever you apply an external pressure, force, or a mechanical stress to the sensors, what it happens is it detects this physical input. This can be a torque, a strain, a pressure change, or structural deformations. So the pressure causes the mechanical deformations in the piezoelectric substrate, which then influences how this acoustic wave travels across it. And this change forms the basic of sensing. So we will look into it detail. So when you look out here, inside this acoustic wave sensors, as I quoted already in the construction part, we have two IDTs. This is the IDT1 and this is maybe the IDT2. And I call it as interdigit transducers. It is looking like a shape of a comb, and that is why it is called, it is a comb-shaped electrodes. And this comb-shaped electrodes are placed in the piezoelectric substrate. So there are usually two sets of electrodes. This is the electrode set 1 and this is the set 2. The major part of this first one, it is used to receive your electrical signal and converts those into the acoustic wave, or I can also call it as a mechanical vibration. And now it travels along the substrate. There is a second IDT, that is a second interdigit electrodes. This will detect this traveling wave and convert it back into an electrical signal. So what happens here actually is whenever you apply a sound energy or whenever you apply any kind of mechanical stress, or it is taken back as a pressure to the IDT. So what is happening here? The electrical signal is being generated and the transducer is converting those electrical signal into acoustic wave. And when this acoustic wave is traveling, on you all know the basics that whenever the signal is traveling, there may be an amplitude of a signal, and this will create to the frequency that is 1 by time period of a signal. So based on the pressure and based on the input you apply and based on the space, the length and shape of this wave gets varied, and this spacing will decide the frequency and sensitivity of the device. So what happens here in this particular operation is that you have to understand the basics that the acoustic wave is a mechanical wave which is being generated by the piezoelectric when an electrical signal is passed to the first IDT. Later, this wave travels across the surface of piezoelectric material. So whenever there is a pressure or strain, the material will alter the wave speed, amplitude as well as the frequency. So based on these changes, helps in detecting how much pressure or strain that has occurred. So whenever the acoustic wave sensor is undergoing any kind of pressure or sensor, it obviously converts those mechanical vibrations back into electrical signals. So the output DDT will convert those modified acoustic wave back into the electrical signals. So by analyzing these output, the sensors can determine what physical change occurred in the environment. Hope you're clear with the acoustic wave sensor. We would like to have a recap of this particular concept. So the base is that I'm applying an electrical input signal with the help of the interdigit transducers, which is placed on the piezoelectric substrate, and acoustic wave generation is happening, and the wavelength and the frequency of the acoustic wave sensor change according to the mechanical stress or the force I apply to the device. So again, there is another IDT which converts those vibrations or mechanical signals into an electrical signal output. So this is the basic working of the acoustic wave sensor. So what are the characteristics of acoustic sensor is that it has high sensitivity to environmental change. It operates on piezoelectric effect. It is frequency dependent response, and it is very compact and easily integrable with any kind of MEMS device. And the major characteristics is that it is suitable for real-time monitoring also. So next, when we look into the advantages of it, as it is mentioned earlier, it is very small in size, it is lightweight, it can able to detect a chemical, physical or any kind of biological parameter. It is compatible with the MEMS device. So the major disadvantage is that it is very sensitive to the external environmental disturbance like temperature or humidity, and it has very limited sensing range. It requires precise fabrication of piezoelectric materials, and this circuit will need a complex signal processing circuits. It is fragile. Actually, the piezoelectric material is fragile. It is used in harsh environments. So application wise, we have already seen in the earlier slide, it is used in automotive industries, in medical, in telecommunication, and in industrial applications. Hope this video gives you a clear knowledge about the working of the acoustic wave sensors. Have a great day. I would like to end the video with a quote. Innovation is like a Wi-Fi. Everyone wants the connection. Few knows the password. Thank you.